Hello, good morning. I am Chetan Singh Solanki from Indian Institute of Technology, Bombay. I would like to thank first of all the conference organizers for giving me this opportunity to talk about the topic which is solar entrepreneurial ecosystem by locals and for locals. So I am going to talk on the following contents. So first of all, I'm going to give an idea about the energy access and what the whole world is trying to achieve, and then I will start with our solar Urja Lamp program, followed by an idea about how to localize the energy activities for installation and even manufacturing. That will build the scenario for what we call is a solar ecosystem by local for local. So that is going to be the outline of my talk. First of all, to begin with, we know that Sustainable Development Goal 7 talks about providing complete energy access to the population all over the world by 2030. So it reads as it ensure energy access to affordable, reliable, sustainable and modern energy for all. Now if you look at the chart at the right hand side, which is actually taking care of all sustainable development goals, and we know that there are some 178 targets defined under sustainable development goals, and the connection of energy is there with 125 targets. So energy access is very, very important. It affects the education, it affects the environment, it affects the women empowerment, equality, economic growth, everything, and everything is affected by energy, and therefore energy access in a sustainable manner is very important. So look at the slide number 5 and look at the access on particular to the electricity access in the world, and still we are almost talking about around 1 billion people all across the world who still do not have access to energy. So having such an important role, and still so many people are not having access to energy. If I talk about India in particular, India has been doing a wonderful work in providing electricity access, but even today there are about 200 million people in India alone which do not have connection with the electricity. So this is the background, and not only this, not only providing energy access, but quality of the access and the reliability of access. So even if in the remote areas, difficult geographically difficult areas, even if there is electricity connection, the availability of electricity or the, I would say, continuous availability of electricity is difficult or not there. So therefore one is having access to electricity, and second problem is quality and the reliability of that access is very important. So having set this context of energy access, we have taken this initiative to how to provide energy access to each and everyone in the country, in the world, but more importantly in sustainable manner. So look at the electricity ladder in slide number 8, which is we start with a very low amount of electricity consumption just for the study purpose. We believe that study is one of the most critical requirement for human development. But after that, you need more light to illuminate in the entire house. We need electricity for running your fan, TV, refrigerator. You need electricity for irrigation, and even ultimately you need electricity for production purposes. So this is the electricity ladder. We need not to go from one step to other, but we can actually create an ecosystem in such a manner that many of these steps can be addressed simultaneously. So let me come back. Let me go to our solar Urja Lamp program, which has been very successful in providing such an access in a very quick time. So the background of solar Urja Lamp, by the Urja means energy in Hindi. So solar energy lamp program basically. The context in which we have started this program is considering that about 71% students are enrolled in the schools which are in a rural area where access to electricity is a problem. Either it is not there, or if it is there, then it is intermittent and it not continuous, and that has direct impact on the dropout rates of student in the schools. And we can see this from the yellow bars, which are the student enrollment in a rural area, with respect to the blue bars, which are the student enrollment in urban area, and how the dropout rates are much higher in the rural area. And there are many factors for this, but we believe that availability of the solar light or the clean light is one of the reason. Now when we started this program, we started looking at off-grid solar lamp program, because off-grid solar lamp or the solar lamp as such is not a new device. All over the world people have been using this solar lamp for 30 years, 40 years now. But why it is still not replaced every kerosene lamp on the earth? And we have kind of looked at the literature, we have kind of looked at the field personally. So we believe that there are three main problems. What we do normally is, it is a charity driven model. So people actually buy it and supply it, and there is no technical support available to repair it if anything goes wrong, and many times small things can go wrong. And third thing is, a continuous availability of the solar lamps are not possible because it's a program driven. As a result of that, it results in three problems. That it results in a higher cost because the product goes in various hands. Lack of technical knowledge in a local area results in a failure of the product prematurely before its lifetime. And the continuous availability is also a problem. So how to solve these three problems so that we can provide this access in sustainable manner? So at IIT Bombay, we have come with this model, which is we call it LAS model. So localization, affordability and saturation. So localization means that can we not do every operation of a solar lamp assembly, or for that matter any solar product in a rural area? Can I assemble locally? Can I supply locally? Can I repair locally? Or even can I manufacture locally? And answer is yes to many of these questions. Second thing is, we have to make sure that the technology solution that we are providing is affordable. So therefore we have designed the lamp just to fulfill the reading requirement, where the light requirements are not very high. So even a 1 watt panel can provide around 150 lux of light over a 45 centimeter diameter, which is good enough to illuminate any book. And if your power requirement is just 1 watt, your battery is going to be small, your panel is going to be small, and that is how we can appropriate the technology for a particular use so that it becomes affordable. And third thing is saturation. So one thing is involving local community, and other thing is how we can get the economy of scale benefit. So for that we have adopted this idea of saturation. So once we take a geographical area, every child in that area is our target, so that I can get higher number of kind of beneficiaries in that area, and therefore I can have better viability of transportation of material, better viability of repair and maintenance services, etc. So this is the three model that we adopted, and our solar lamp project, I would say, is going very well. And this is so once we do localization, what happens is we get a better viability. Once we get a saturation, we get an economy of scale. Once we make it affordable, it spreads very fast. So these three models are very important. Now this three concept of localization, affordability and saturation are all well connected with each other. So for example, you can see from slide number 14 that if you localize, then what happens? Affordability increases because your cost decreases, your service cost decreases. And if you make it affordable, saturation increases because it is affordable to everyone. Everyone want to actually would have capacity to buy it, and therefore your saturation increases. If your saturation increases, it further enhances the affordability, it further enhances the localization. So therefore these three idea of localization, affordability and saturation is, I think, the basic principle that one can adopt in any technology based intervention for providing energy access. All right. So we have been doing this program we started in 2012, and one can actually go to our website www.soulsIITB.in and find out all the details and how we implement the program. So what we do is we involve local community in assembling of the solar product. We give them training, we give them the raw material, they assemble the product. Then the local community, and mainly the women we are working, so this women actually then go to the school and sell it to the student. By the way, it is not given free, so they have to sell it to the student. And because they are local, they also actually start repair shops, so that anything goes wrong with the lamp, they only can repair. So this is how the entire system works. So local community assembles the lamp, local community sells the lamp, and also local community repairs the lamp. So far, look at in the slide number 15, we have actually reached to 2.7 million students, which almost means that 2.7 million households. We are working in 104 sub-districts, and some 3,500 women are working right now. But the target is around 5.8 million more. So in total, we will be reaching almost around 8 million beneficiary in a very quick time. So these are the slide number 16 shows various states that we are working: UP, Uttar Pradesh, Madhya Pradesh, Rajasthan, Maharashtra, Chhattisgarh, Odisha, Assam, Bihar, Jharkhand. So as you can see that our program is really widespread, and it is taking care of the majority part of the Indian states. So now once we do this, once we involve local community to do all the operations related to assembly, supply, distribution, repair, maintenance, what happens? It actually creates an enormous benefit to the society. It first of all creates livelihood, because these women who are now assembling the solar lamp and distributing gets a livelihood opportunity. They earn money out of it. But not only that, it increases the study hours of student. It creates a confidence in the technology. It creates assets in a rural economy. It helps into empowering women. It increases their standing in the house and in the society. Many things happen. So though it is a very small solar lamp, but the impact on the society is enormous. I would like to share you some of the photographs, how things are happening. So in this photograph, women is doing soldering. By the way, many women first time in their life touch any such equipment, electronic equipment. So it is a huge experience and change for them to learn these things. But they learn beautifully. So they are doing the soldering. Here they assemble the entire solar lamp. They also test the solar lamp and the solar component if they are working and not working. Then the women actually have to go out and talk about the solar lamp program to the other community in the community and the schools. And then eventually students get their solar lamps and they use it for study purpose, but it can be used for any other purpose also. Okay, so now that is how about the solar lamp program. But as I said, this idea is not just giving small electricity for a lamp, but how I can supply the entire electricity needs of a community in a sustainable manner. So how can we go beyond a solar lamp is the next idea. So first of all, our earlier program was called Solar Lamp Program, Solar Urja Lamp, but now we have changed it to Solar Urja through localization for sustainability. So in slide number 25, so you can see very clearly that sustainability is the core in the all. So as we are going and trying to provide more and more electricity access, but this access should also be sustained. So what we need to do is not only attain electricity access, but also sustain electricity access. So can we provide 24/7 electricity access, which is the big challenge as there are still 1 billion people, and how I make it cheaper, reliable, clean and sustainable. So first of all, one of the things that is making it possible today is the development of technology. So all of you are aware that solar technology has really evolved in a big way. It has now actually matured, and the solar modules are available in the less than $0.50 per watt, which is really a tremendous achievement. But not only that, my solar panels are cheaper. I would like to take your attention to slide number 27, where when you look at the entire solar system, I need a load, then I need a kind of battery and a controller, and then I need a solar PV module. If I can reduce the power requirement of a load, my entire system becomes smaller, my battery and panel becomes smaller. So what we have done is, we are now actually working with the Lawrence Berkeley National Lab in US, where they organize this competition for super efficient devices. And all this majority of devices, which are like TV, fan, light, mobile charger, everything runs on solar DC. Okay. So when it runs on DC and they are super efficient, my power requirements are very low. So I can run a TV of 23 inch in just 13 to 14 watt of power. There can be a table fan which may consume less than 10 watt of power. There can be a DC ceiling fan which will consume around 25 watt of power. All we know that LED bulbs can take just 3 watt and 5 watt of power. So basically my system requirements are very low, which actually means that my battery will also be low and my panel requirement will also be low. So therefore I can design a system in just 50 to 100 watt of power. I can fulfill entire need of an household: TV, light, fan, mobile charger, radio, everything can be supplied, and therefore I can make 24/7 solution based on the solar itself. We did not to go and supply the grid solution. Solar itself can provide 24/7. If I want to do that, slide number 28, I need to provide the both benefit of being local and benefit of being global. So in the ecosystem, benefit of local is there because local community is involved. But if I aggregate the entire demand of the area, where I can actually then have a large scale to operate, then I will have economy of scale. I would have a better control of the quality and the better supply chain management. So if I want to make this ecosystem efficient and reliable, we need to bring both benefit of global as well as local, which we are trying to do in our program. So basically the entire ecosystem we think is that there has to be some manufacturing and assembling or demand aggregator units around which there can be many solar shops in a rural area, and each of these solar shops then can service to many households in that area. So their access to service is easy. So this is the kind of local supply and service mechanism that we can think of. Now again there are examples of how we have implemented this program. There are solar shops that people have started, women have started. There are households where we are installing 24/7 solar electricity solution. So this is an image, slide number 31, where how women are actually making entire electricity arrangement on their own based on the solar. They do the electricity wiring of the house also, and then eventually can run the entire house 24/7. Alright, so then one question is, can we also not, so not only that we provide local services, supply everything, but can we not also manufacture locally? And we have been actually contemplating on this idea that, for example, solar modules require for off-grid products, street light, water pump, home lighting system, actually not very big modules. We need modules in the range of 20 watt, 40 watt, 50 watt. And manufacturing of this small power modules also requires a lot of manpower, which is easily available in remote areas. And therefore, can we think of localized manufacturing? So we have worked on the module manufacturing, and slide number 36 shows all the machines that is required in the module manufacturing, which is actually standard module manufacturing process, adopted all over the world. Once I actually make my modules local, we can actually make a lot of products locally. All products that are shown in 37 slide can be made locally. And again, we have gone ahead, we have established such a factory which is owned and operated by local tribal communities, and these are the images. So slide number 38 shows how these women are actually doing the soldering, and they are connecting solar cells in series in a module. They are testing the modules. Once they make the modules, there is a training that we have provided that they can make a solar street lights out of these modules, and they can actually do the rooftop based solar installations. So everything is done by women community. So what I have shown here is how we can create an entire ecosystem, where every operation is done by rural community, and that actually increases the sustenance chances of not only generating electricity but also it gives economic empowerment to the rural community. So that brings me to my final idea about what we call is a solar energy ecosystem buy local for local. And the beautiful acronym here is a cell model, that time has come now when the technology has evolved enough so that we need not to actually go by the subsidy or charity driven model, but it can be a market driven model. So we need to create solar ecosystem buy local for local. And a lot of thinking has gone into it, that basically the cell model is very simple, that all my operations are local, assembly, service, supply, manufacturing, financing, capacity building, demand aggregation, all are these local operations. And this local ecosystem actually interacts with outside world in kind of sourcing some of the materials, sometimes technical knowledge, sometimes expertise. So this entire thing is shown in slide number 43. Then there are various benefits of setting the cells. So it will actually particularly look at the output and sustainability, livelihood generation, energy security, women empowerment, climate mitigation and adoption, enterprise promotion, technology diffusion. All things are my output. And IIT Bombay has been doing all kind of program. So it's starting with the just small assembly and distribution. Then we added in our program the enterprise activity. Then we further added in our program the solar localized manufacturing. So now there is an experience, and the actual experiment that we have performed, where we establish a cell model, and our idea is now to replicate this cell model in every parts of the country. So with this I would like to conclude. I would like to acknowledge the contribution of Ministry of New and Renewable Energy, the administration of IIT Bombay, and all the faculty colleagues at IIT Bombay, and the staff member at the SOLS office who has contributed in this experiment. So thank you very much for your attention, and if you want more details about the program, you can go to the website solsiitb.in, or if you have any particular query, you can write to me at chetanss@iitb.ac.in. So with this, once again, I would like to thank the organizers of the conference and giving me this opportunity to contribute in the conference. I hope this talk will be useful for many who are interested in sustainable energy access. Thank you very much. I would also like to invite you people to visit our YouTube page, where a lot of these videos are available, and this particular video will also be available on the YouTube page. Also, you may visit the Facebook page for which the address is given here. Thank you very much.